and welcome to Sustain, the podcast where we talk about sustaining open source for the long haul. Who are we? Where do we come from? Where are we going? How can we reproduce that entire sentence again and again and again and again without failing to do it correctly or something of that nature? Very excited to talk to our guest today. Before we get to our guest, I want to make sure you know who the other voice is on this podcast. I'm, of course, Richard Littauer. Hi, everyone. Never using that voice again. I apologize. And we also have Abby Mays. Abby, how you doing?
I'm good. How's it going?
It's going pretty good. It's too hot, but that's okay. That's just what happens when the equator tilts. Joining us from another warm part of the country, we have Karthik Ram on the podcast. Karthik, it's great to have you. Thank you so much for coming. How are you doing?
I'm doing great. Thank you, Richard and Abby, for having me. It's fun to be on this podcast after listening to it for a while.
I'm so sorry that you ever had to listen to it. I hope it was an enjoyable experience for you. Karthik is a longtime sustainer, which is a term we use for people in the sustain community in general. He was at the sustain event in Brussels. I don't know if you're at any of the other ones. Were you?
That was the only one I've been to.
Cool. Well, it's great to have you. Karthik is a research scientist at UC Berkeley's Institute for Data Science and Berkeley Initiative for Global Change Biology. His research is interdisciplinary and covers areas such as understanding impacts of climate change on ecological communities, reproducible research, sustainable scientific software, and open science. He's also the co-founder and director of the rOpenSci project and a lead at URSSI or URSSI. Additionally, he's a founder and editor at the Journal of Open Source Software, JOSS, and founding editor for the rOpenSci software review. So you know a lot about this subject. I think let's start off with asking about what do you do as a senior data scientist at your current job?
I think I consider myself kind of a janitor, taking care of various things that sustain different types of projects. So I don't consider myself an individual contributor anymore because I don't write code that much day to day, but I'm sort of like an engineering manager, project director, a fundraiser, and mentor for students, postdocs, research software engineers, and other people that occupy this space that are traditionally not considered in academic roles, people like community managers, for example.
The word janitor is interesting. It makes it sound almost custodial, but you're also, mentor, gardener, there's other ones, right?
Yeah, I think gardener is probably better, but I feel like I'm picking up all kinds of pieces and stopping them from hitting the ground. And it's hard for me to find the right term to describe that kind of role sometimes.
How did you end up in that role? Because I know you traditionally had like an academic bent. So what happened?
Yeah, so I started out as a field ecologist. My goal was just to be a traditional tenure track faculty at some point in my life. And I transitioned from doing field research to then thinking about a similar concept, but at a much larger scale involving decades of data. And so in 2009, 2010, I was in this postdoc that required no field work. And I was just handed lots of data at the time. It was the same time big data was being coined as a term and just getting thrown into the deep end. So for me, I had to figure out what version control was. I invented my own terrible form of version control before someone over lunch told me that this is an actual concept that exists in computer science. And I just started writing lots and lots of code every day. And then my frustration with lack of good software led me to think about software practices. It's basically what inspired me to talk to other people and then get rOpenSci going. And then before long, I realized I enjoy doing this type of work much better than traditional field research for various reasons. I still enjoy that kind of work, but working in the field and having the uncertainty of various elements, like a flood destroying your field site 2 years into an experiment, were things that I did not miss. And so before long, or one side projects for me became full-time projects. And then before long, many other projects and activities started to fill this space. And then when Berkeley started a data science institute, I basically switched departments, joined them. I, for a brief time, maintained a 50-50 appointment across my domain research and the data science department. But now for many years, I've been full-time in the data science division. So that's my long road into this space.
I can't believe you wrote your own version control system. But I see how understanding what you were doing was duplicating existing work, how that's affected so much of your career today, because you're really helping in that space and just making sure researchers know these best practices.
Yeah, it's fascinating. When I started that project, I was told a lot of things during the interview, that all the data is already processed, downscaled, ready to go. You could write a paper in under a month, possibly, if you get going. And then as I started poking through, I just started finding inconsistencies after inconsistencies. And so then I tried to track down a protocol. There was no protocol. I had to track down a former employee who had done a lot of the work, and he gave me bits and pieces that he had done. And then a year later, I realized that a lot of it was done incorrectly. And so then I started writing everything in code, documenting everything. And that frustration is what led me to think more actively about software. Yeah.
I'm sorry I had to go through all that, but I am glad that you're helping prevent this in the field generally. Thank you.
Yeah.
I have a lot of questions. I think I want to start with Arfan. I realize we haven't had him on the podcast either, which is strange. So tell me about JOSS, the Journal of Open Source Science, and how that grew out of this as well.
Yeah, so I should probably make a minor correction to your intro bio, which is that I am no longer an editor there. I used to be. I think Abby was an editor too, maybe even in the same cohort as me. I've graduated out of being an editor mostly for time reasons, but I think it's kind of a fascinating story also. I think I'm going to go a little deeper and give you kind of the origin story for the whole software review process. So when we started URSSI, for those of you that don't know, it's an organization that is a software federation for researchers to either come for tools or a place for them to sort of deposit their tools that they've built. When we first started in 2010, writing software was hard. A lot of researchers were not writing software, and we were in the business of developing tools for researchers that we thought was important. And we handed it out to people. So people would tell us, this is really important to me. And then if we heard that from enough people, we would go build a tool for it. But I think over time, we quickly realized that software was becoming easier to develop, that more and more people were building their own software, but they were not really up to speed on best practices. So they would bring their puppy and ask us to adopt it. And so we would ask a whole bunch of different questions. Is it potty trained? What else have you done? And then before long, we turned that into a checklist. And so we were asking people the exact same questions. And so we thought, well, the more efficient way is just to have an intake form where you ask people all these questions. That led to coming up with a process where we wanted someone else to do a gut check on the software. So we started getting a technical review. And then before long, we realized we would like a review from someone who might be a potential user of the software, who might not necessarily know much about the technical details. And that's how we started our OpenSci software peer review. And I think about a year into that, Arfan and I were talking about how to get credit for research software. And he wanted to generalize this process to any research software and then make sure that we were meeting a checklist. It was passing a couple of high-level reviews, and then we were publishing a paper to go along with it. So that's how JOSS started. JOSS has been doing great. It's published thousands of papers at this point, has had easily over 100 editors by now.
And reviewers who are also good people. So as one of them, he said, self-admittedly. Tell me about the Data Institute at Berkeley. You said that they started it, but I'm actually really curious what that's like as well, because it seems to also be going along with this general move towards, we can't just research, we have to think about the entire part of research and what that means on the academic level. So I'm curious, how did that begin and what was your role there?
So if I remember correctly, I think a lot of things happened in 2010. So data science was just coined as a term by DJ Patel. Everybody was trying to hire data scientists, whether or not they knew what that meant. And then every university in the country was trying to start a data science institute. Maybe not every university. Now, almost every university has one. But in 2010, a handful were trying to think about it. And I think it grew out of the recognition that open source was important. Data and big data was playing an increasingly important role in a bunch of different fields. And you cannot work with large, complex data without good software. So they kind of went hand in hand. And Berkeley jumped on an opportunity to get funding from the Gordon and Betty Moore and the Sloan Foundation and really create a home for the misfits in different departments, people who are part researcher, part data scientist, part hacker, part open source software developer, give them a home and again, give them a reason to collaborate with each other and sort of cross-pollinate ideas. So that's how we started in 2013. I think we just celebrated or are about to celebrate 10 years. But yeah, a lot of the work that the staff scientists do, and we're not very many, we're only a handful, is that we have our own research program for which we get funding and people and try to pull in students and postdocs from around campus who might be interested in working with us.
So I'm really glad you mentioned research software in general, because that reminds me of URSSI, which is another thing you're the lead of. And I feel like this entire episode is just mentioning all sorts of stuff over and over again. It's just all explication, for which I apologize. But can you tell me how your work there led to URSSI and what's that doing?
Yeah, I think they're all very closely interrelated in some ways. So the work at URSSI kind of led to JOS being created. And as all these projects were coming together, we were starting to see these challenges emerge across a much higher level, which is people were producing software in different languages. They didn't really know the best practices for software, and they didn't have any ideas on how to sustain these projects. And then there are issues around raising funding or trying to come up with a business practice that might make sense for your open source project if you really wanted to work hard at sustaining it. And then there are aspects of community engagement and growing a user community and a developer community around your project. And it's not something that comes naturally to a lot of people, not even me. And so it's something I had to work at. And now I collaborate with other organizations that specialize in community development. And so we wanted to have a place where we could collect all these best practices, disseminate the best practices, advocate for policy at a national level that would support people developing the software and the software itself and communities of people working on software. So that's kind of our vision. I think one of the challenges with URSSI is that it's taken a very long time to get it off the ground. And only last year, we received a whole bunch of funding to kick off a whole bunch of different projects. So we're still very much in the space of recruiting and trying to get activities off the ground, but we have a whole bunch of activities lined up.
I'm very excited about the projects coming up. Anything you want to highlight?
One of the big URSSI projects that will kick off in the fall is that we're going to run a school on research software engineering. So to me, the idea is fairly straightforward. We teach people how to code, and occasionally we teach people how to write software, but we never go beyond the basics. And so if you think of software carpentry, it's sort of like riding a bike 101. It's like how to use software, how to write functions, how to write loops. And to me, it's sort of like an introduction to using open source software for your research. It's meant to make things less daunting. When you go to data carpentry, they're teaching you how to use open source tools to acquire data, wrangle data, process it, and get more comfortable with the idea of doing that with your own research. And then you kind of graduate from that, and you might learn how to put a Python package together on your own. You might attend a workshop where someone teaches you how to build your first R package, but you're still just kind of scratching the surface. There's so many more other things that you need to be aware of, and there's not really a place to learn that. So when we started thinking about this, we couldn't find a good place to learn this. So when we ran the planning process for URSSI, one of the things that we did with some of our extra funding was we ran a week-long winter schools for research software engineering. And we had a ton of people applying for the 50 spots that we had. And when people showed up, they were super excited to actually have a place to talk about their projects, connect with each other, commiserate about the challenges with Git, continuous integration, continuous delivery, in a way in which they couldn't get into in other places. And so we realized there's a massive appetite for this. And so we made that one of the core projects that URSSI would do once we became a full institute. So that's one of the things that we're really excited to launch. So it's being led by Kyle Niemeyer, who's one of the URSSI steering committee members. He's a professor at Oregon State, and I'm very excited for Kyle to kick this off in the fall.
That's awesome. And I do think it will have a big impact on sustainability of research software, just people understanding these best practices. How did you think of the topics that would be part of this, or is Kyle still putting this together?
Well, we put it together for the first time. And so we basically looked at other courses and materials. We basically had topics from workshops that I had done before and a class that Kyle had taught before. So I'm glad you mentioned the fact that all of this feeds into sustainability, because it kind of allows me to segue into a different topic, which has been a pet peeve of mine, which is that even today in 2023, we do not have a good appreciation for research software and the role that it plays in driving research on all the things that we care about. Things like climate change, pandemics, infectious disease, all this cancer, all this is made possible by research software. We don't have a good understanding of what are the different tools that are helping us uncover research in these different fields. And we really don't have an idea of how many of them are sustainable and how many of them are not. And another pet peeve that I have is that people think money is the solution to everything. So when people say software's not sustainable, we just need more money. Actually, that is not true. There are many projects that have lots of money, but they're not really sustainable. But it all ties back to Abby's point, which is that if we teach more projects about best practices, it's very likely that software that integrates those best practices will actually continue to exist a little bit longer, function a little bit longer, therefore make the ecosystem less vulnerable to just falling apart very easily. I sort of think of it as like a car driving, and all it takes is just one tiny pebble on the road to just derail the whole thing.
So you mentioned the word software sustainability, but also with the sciences. And we don't have a ton of scientists on this podcast. And so I'm curious, what's different about scientific software sustainability versus normal open source software sustainability, whatever that means? Like, what special thing is science sustainability?
I mean, there's lots of commonalities between the two. And I've always thought of sustainability from the perspective of research software, not just open source more generally, because I think business needs are a little bit different. And there's usually lots of competing options for type of software where there's a lot of business need. So there's potential for switching, which might be a little bit easier in a commercial context. But I think the challenge with research software is that there's a lot of software that sits on the long tail, because these are niche tools built by a handful of people with very specialized domain expertise, catering to another small group of people that might think about it. So there's not a ton of users. So you're not getting a lot of eyeballs. You're not getting a lot of developers. And it's very expensive to build these tools. And when they disappear, it can set a field back by quite a bit. So to me, that's one of the more unique challenges of research software that you might not necessarily see with open source more generally.
Can you give me an example of a field that's been set back through a project that died?
Nothing comes to mind immediately off the top of my head, but I think that is one of the challenges too, right? If you ask a bunch of cancer biologists, can you tell me exactly what tools and types of tools are really critical to your field? They're like, I have no idea. I can tell you what I use, but it's hard for me to tell what other people are using. And then if you dig deeper and ask them, how did you find these tools? They don't really have a good answer for that either. They'll tell you, well, it's the first thing that showed up in a Google search. It's what I saw somebody tweet about. And the reason why I mentioned these two things is I've been doing a focus group trying to understand research software sustainability. And these are common answers that I get. When I ask about how do you discover new software, it's usually, I used to see it on Twitter, but now that Twitter's dead, I'm not sure where to find software. Or it's probably on the first page of a Google search, and that's how I find it. And to me, this is shocking because you're about to invest in a tool that you might use for 6 months to a year to 2 years. It might be the foundation for your research. And you don't even know if this was tested correctly, if this was built by someone with correct understanding of your field, with correct domain context. You just pull something off the shelf without really reading the label. And as long as the code works, it's like, great, now it's plugged into the rest of my workflow. And to me, that is shocking because we need better tools for discovery. We need better context for discovery. a better understanding of the limitations of a tool so people can really make the right choices for something as big as an outcome that might impact a very large number of people.
You've talked a lot about community building. You've talked about reproducibility. You've talked a bit about unhealthy dynamics in a project that can't be fixed by money. I'm curious, where is your next cool acronym of community working on building better search tools to find better software? What's happening there in that space? Is that a thing that you're working on?
Yeah, absolutely. So I'm currently working with two very cool people. One of them is Patrice Lopez. He's a machine learning researcher in France. He runs his own organization called Science Miner. It's science-miner.com, I believe. And James Howison, who is a professor at the University of Texas at Austin. He works at the Information School. One of the key things that I'm interested in understanding is what tools do researchers use? What do they use in a particular domain of research? How does that use evolve over time? And then can we start to identify clusters of tools that are driving discovery in a certain area of research? And to me, the really challenging thing is that if, say, you published a paper and you had a little manifest that told me all the software that you used with that paper, life would be simple. It would be so simple. I could search for all the papers in the field, find all the software manifests, and analyze them in aggregate. I could analyze them over time. I could start to see when people are migrating from certain tools to a better tool. And in sciences, this sort of migration takes a lot of time. There's a lot of lag. So I remember, at least in the art community, people were using a tool called Plier for a very long time to manipulate data. And a better tool came along and all the early adopters switched. But just looking at GitHub, I could tell many researchers were still using the older tools because it took a while for all the tutorials to catch up, for them to really get comfortable leaving behind something they knew well into something that was a little bit different. So to be able to look at all these trends from a bird's eye view would be really amazing because you can tell exactly when a field is switching from one set of tools to a different set of tools. And that could be really useful, right? Because if you're a funder, you can figure out where to put money. If you're someone just entering the field, you know what skills you want to pick up. You don't want to pick up outdated skills that a year or two in, someone's like, well, nobody uses that stack anymore, so it's time for you to start over. And it truly saves a lot of funding and taxpayer dollars. So we're not wasting time trying to use tools that are not optimal, that have sort of maybe already gone on the path of end of life and people haven't found out yet. I see this with my own work. I archived certain pieces of software because I'm not able to maintain them anymore. I put a notice for 6 months saying in 6 months, this will stop working. You need to switch. It is archived on GitHub. And even now people find the most interesting ways to get in touch with me to tell me that they're still using that software. And if I could go through and fix a bug.
That's great. Yeah. And as someone who spent the first part of my career learning Perl and using BioPerl, I really appreciate you working on this problem. It's like, oh, maybe you should use maybe Python, maybe something that has a little bit more of a community around it. That's awesome. Yeah. I didn't know about this.
So going back to reality, which is that people don't really include this kind of software manifest. And so we are now left trying to guess what tools might be used in a paper. And so this is the magic of a tool called Grobid that Patrice Lopez has built. And Grobid can process any structured document, turn that into XML and extract entities in them. And so we can extract entities like names, institutions, software, any instruments that might have been used. And James and Patrice worked on an annotated training data set for scientific software so that we could run a model to uncover software that might have been used in a paper. So in terms of a workflow, we can feed the software mentions recognizer PDF, and then it would go through and then identify software that might have been used, disambiguate them, and only retain scientific software. And it also captures the context in the paper's text around the mention of the software and makes all this data available. So it's all machine actionable data. So to me, the cool things you can then start to do is feed the software mentions recognizer corpus of papers and then start to get data that you can use to build out a knowledge graph. So you can get things like software that's been used, what languages are they from. We can go get more metadata about the software. We can get information about the authors. We can get the title of the paper. We can get some keywords about the paper. And then suddenly you can start to model out what software use in a community looks like, how the use of that particular piece of software changes over time, how different pieces of software might be used alongside each other, which to me is very interesting because how people in the real world use software is different from information that you can glean automatically through software dependencies. So you might have a particular tool that pre-processes data in a certain way that feeds very nicely into my tool, which does data visualization. They're not linked by any kind of hard dependencies, but people use them together often enough in the real world that there's almost a soft dependency between them. It's like an information flow dependency. Information comes out of your tool into my tool. If you can start to see patterns like that, an amazing intervention that you could do is put the two of you together, or at least the two of us together, to coordinate our roadmaps to make the process more friction-free and make life easier for researchers, because that's how they're using our two tools together. This is really hard to pick up unless you have direct access to workflows, which is another thing people don't share. So we are trying to infer all this information out of PDFs. And because you have the context for where the software might have been mentioned, you can also start to understand how someone might have used a software. So I'll give you an example. So if you have a pretty large tool that does all kinds of different things, it would be really interesting to see how somebody's using that tool. So someone could be using a particular tool because it's really good at taking data, cleaning it out, and spitting it out as JSON. That might not be the primary purpose of the tool, but it does it really well. And if people start to mention that in their papers, that we use this tool to pre-process the data because it's really fast, really efficient, then the developer might be interested in understanding, oh, I didn't really know that this is how people were using my tool. I never intended it for that purpose, but some helper functions I've had in the library seem to have played out this way. So I think there's a lot of potential for this kind of software mentions work to really drive our understanding of how software is helping research, and also start to uncover things that you might have talked about in different podcasts too, right? Like the sole maintainer holding up an entire field of research. We can start to see who that person is and then go and try and support them.
Yeah, and I think that interoperability piece that you were talking about, it's a really interesting way to potentially find standards or like define new standards and help more of these tools work together really well. So
absolutely.
Cool.
Yeah. I'm glad you framed it as standards, because we really want people to start aligning their roadmaps when they're not really set up to talk to each other.
Robid's README has a section at the bottom saying how to cite this if you're interested in citing it. And it's a MISC tag in a BibTeX file, which I think is kind of sad because I wish there was like a software tag. Like, can we get to that already? It's awesome that you're inferring usage of tools using machine learning. That makes a lot of sense. It's really smart. I love it. What would you do that's more proactive to encourage, say, universities or researchers to publish their entire workflows and methodologies better? How can we better do that? Is it just setting up a GitHub repo for every single paper that we write? Or is there something else?
I think the challenge is that we don't really need to invent anything new. So we've got code hosting platforms, we've got repositories, we've got best practices which evolve over time. So you can never write static best practices and leave them in one place. And I think the issue that you raised is kind of the reason why we would like URSSI to exist, is because if I was a regular researcher, not someone working in software, there are so many topics to keep track of. GitHub is still very popular today. It may not be in a year or two or in 10 years. How do you know where you should be putting your code, where you should be putting archival copies of your code? What are good practices to document your dependencies? Do you put in a requirements file? Do you put in software bill of materials that you can generate with one of many free tools? What exactly do you do? This information is there. It's all over the web. I'm sure Abby and I both have some version of best practices in our talks and other places, but it's really hard to tell which of this is current, which of this is still useful. Does it really apply to my domain? And is this what my community does? So we'd like to have a place where researchers that belong to a community can come find the canonical set of best practices that is current of what they should do. Because I do believe that a lot of researchers would like to do the right thing. They're just not sure what exactly to do. So they do the scattershot approach. I talked to a researcher recently and she said, I tell my lab that they should put everything on GitHub because that is a permanent archive. And I couldn't tell her during that call that, oh, no, GitHub is not permanent. You could delete your account. Your account could get locked out. You could get hacked. GitHub could shut down and go the way of SourceForge or Google Code. Many things can happen. So unless you're putting in a CLOCKS repository, which is an acronym I can never fully remember, but I think it's keep multiple copies. At least that's the general theme. So putting that in a CLOCKS safe repository like Zenodo, which you can now easily integrate GitHub and Zenodo together. So every time you make a release, there's a release made on Zenodo and there's a DOI going with it. I think these are examples of best practices that people should be thinking of.
Lots of copies keep stuff safe with a C on the beginning. I don't know what the initial C is anymore. It came out of the LOCKS project, I think.
Exactly.
I was reading my master's thesis this weekend and I had some suggestions to throw stuff on IPFS. And I'm like, whoa, man, is that dated? I mean, great. That's cool. You should do that. But then like, who's going to find it? And even best practices papers go out of fashion so fast. So I like the focus on communities. Yeah. One of the things that's really interesting to me about communities is we already have that in science. We have things like journals. Impact factor was originally meant to be an easy way to find what are the good journals to read. It doesn't really mean that anymore. What it means instead is that we have a system where you have to publish in the highest impact journals or else you're a failure, which is really hard. So I'm curious, how are you planning to mitigate against creating another type of impact factor for code repositories? Do you think that's going to be a problem?
Oh, absolutely not. I don't think there's really an impact factor. I think we are so far behind that I tell people, did you put code anywhere that's publicly accessible? I think you're doing way better than anyone else I know. So to me, that is a good first step. And I think it's sort of something you can do at different levels. So if you do that, that's great. You put it on GitHub. If you put it on GitHub and you put it on Zenodo, even better. If you archive the data that went along with it in a data repository, even better. And then if you truly have a Docker file or a Docker container and a lot more details about your installation setup and a lock file, then I think you're doing so much more better to support future reproducibility of your work.
Yeah, it leads on to my next question, which is, it's great to do all this extra work, put stuff somewhere, make it easy for people to reproduce it, make it easy to maintain for yourself, but that doesn't help you keep your job. Yeah. It's extra work on top of it. So how do we solve the problem that scientific maintainers are even worse off, I think, than, say, industrial maintainers who at least may be able to work on it part-time? What do you do to help people know that, yes, this work is both important, but also is going to help you in your career in some way? I'm just curious.
Yeah, that is a fantastic point. I recently read a paper, I'll share a link to that, which pointed out that the burden of reproducibility tends to fall on people that are already struggling, and it doesn't actually help them advance in their careers. So we're actually creating additional work for people in low-income countries when they're already overburdened with work. But I'd like to separate your question into two parts. The first part is the additional burden of reproducibility and how to deal with that. I think there's a lot of work that we as software people can do to make life easy. So to me, the Zenodo GitHub integration is an example of a simple switch that you can flip or add a config file that makes the process automatic, that you don't have to think about it. Once you do that for one project, it becomes part of your checklist for a project. So reduce the burden of doing that, reduce the cognitive burden of thinking about that. And I think we can do that other places too. If somebody gave me a checklist and said, make a requirements file, put a copy of a workflow on GitHub, archive the code on Zenodo, archive the data on Dryad, publish your paper, but also post a preprint. To me, like, that is a fantastic checklist. And if a lot of people followed that, life would be amazing. So I think that is the way to go, is just make life simpler by automating a lot of things. So the second part, which is, I think you asked about software maintenance and how do we help people do that when it doesn't really help their career? And I think you mentioned in industry, at least they could do that part-time. Yeah, I totally recognize that challenge here. So the way I think about it is this. I think there's a common misconception among the academics who write software that they have to maintain something that they built forever. I think that is not true, and we should not perpetuate that notion. Here's why. I think everything has its own lifespan. So I think if you build software, you can think of that in different stages. So when you first build it, you might have built it for some good reason that you've just identified a new method and you want that captured in code. And the software might be very simple. It's an MVP. It's not really robust. It's not really fast. But you put something out on GitHub, you see what your community thinks of it. It's more of a prototype tool. You're assuming it gains a lot of attention and it starts to find good product market fit, and you're happy with that feedback and you're encouraged by that feedback. You might release a new version, better version, faster version, a lot more tests as part of it. And then you've got something to maintain. And I think that's when you might consider a piece of software becoming research software infrastructure. But I think people should maintain software as long as it's useful for them to maintain it. So if it's no longer relevant to your research, you can move on. Part of the work that we want people to do is identify community early on. So if you invest some time into building community, there will be other people to hand this off to when you're ready to leave. So you don't actually have to feel like this is your burden to carry forward forever. And if you're not able to find a good succession plan and you don't want to maintain this, you could responsibly put it to rest. So you could archive the software, you could put it up for adoption, you could put something on the README that says, in 6 months, I'm going to stop maintaining this. Here are other tools that I recommend that you switch to. And give people enough time. And even after that, if people don't do it, that is not your responsibility. And good ideas will get captured in software many, many times over. So I think if we teach people, these are the practices in the early stages of developing software, when you maintain software and when you're ready to sunset the software, I think we can do a lot of good by the communities. So if somebody finds your software when it's in this end of life stage, they can make an informed choice, then go find a better tool or go to one of the tools that you recommended, rather than accidentally find something, put a lot of time into it, email you a year later. You tell them, oh, I stopped working on this 2 years ago. I put a notice a long time ago. We can avoid those situations and give people more room to be creative, do things that bring them joy, and then responsibly hand them off to the community or sunset the project.
Great answer. Love the focus on joy and only maintaining things that are useful to you currently. Excellent advice. Doesn't solve the problem of sometimes there's too much that's useful to you and you still got to work that out. But you got to keep some problems. Otherwise, we can never have future guests on this podcast because it's done. We've solved it. So, yeah, Karthik, this has been great. We are running up on time. So I want to ask, where can people learn more about your work and the communities that you are involved in?
I have a website, ram.berkeley.edu. That's where you can find a lot of my projects. You can find links to me on the various social media that I'm on these days, which is now Twitter, Mastodon, and Blue Sky. But I think just looking at these links, looking on my GitHub, looking for talks is a good place to stay connected. And people are always welcome to email me.
Sweet. We'll have some of those links as well in the show notes. Thank you so much, Karthik. Don't leave yet. Now we have another part of the program called Spotlight, where we point out people, places, objects, code, which were useful to us in our careers, or we just think need a little bit more light shed on them. Abby, what is your spotlight today?
My spotlight is Governing Open by Shauna Gordon McKeon. Richard and I were at a workshop this morning that Shauna ran.
It was awesome.
It was really good. She put together a bunch of resources in governingopen.com. I haven't clicked through all of it yet, but what she showed during that workshop was amazing and really eye-opening. So looking forward to digging deeper in there. And yeah, I think more eyeballs would be great on that.
Love that. My spotlight, Karthik probably saw this coming, is Bertram Ludasher and Bill Michener. These were two researchers who worked with Karthik on a random research project that I somehow got after college. I don't know how that happened. But Karthik also introduced me to R in the early days. So I'm very grateful to all three of these people. Really cool research. And I'm glad to see that they're still producing awesome work. So I'm going to link to their GitHub scholars. Karthik, what's your spotlight today?
So my spotlight is somebody that I work with who is very modest, but brilliant. His name is Patrice Lopez. I mentioned him early on in the podcast. Patrice builds these amazing tools, and he's very thoughtful in everything that he produces and almost a little too modest. And he's doing a lot to uncover the hidden impact of software on science. So he's my spotlight.
Love that. Thank you so much. Karthik, thank you so much for coming on. It's been a pleasure to have you. Listeners, I hope you have enjoyed this podcast. If you have enjoyed it, there are a few things you can do to make life better for everyone. One of them is you can donate to Sustain. You can go to opencollective.com/SustainOSS. We do take donations. This podcast is not free. Or you can talk to your employer and talk about maybe getting some sort of sponsorship involved. That would be really dope. Second, you can like us on Apple, Spotify, wherever you're finding this thing. Third, you can go to podcast.sustainoss.org and check out these show notes. Go look at it. Go share it with your friends. That'd be really sweet. Look at past episodes. Suggest future guests. And you can comment by emailing podcast@sustainoss.org. That goes to all the hosts. We would happy to get your questions and answers. We've had like one email so far. Please spam me, please. Also, you can go to discourse.sustainoss.org if you want to talk about people live on like some sort of weird forum site. That would be really cool too. Finally, you can also come to our Sustain conference, which we are holding on July 12th in Portland, Oregon. We have a capacity for 80 people, and it would be awesome if too many people signed up. So please come to Portland. It's right before FOSSI, which is also going to be a very fun conference, unless all of my 4 talks get rejected. I don't know why I submitted that many or why I'm still talking. Check out more on sustainoss.org. Karthik, thank you again. This was great. Good luck. Keep us updated, and so long.
Thank you, Richard and Abby. It's been fun.